Luc, could you just share some experience about your role and responsibilities today at Lyft and your previous role at Google?
Yes, indeed. So today at Lyft, I lead the team we call Lyft Level 5, which is focused on building self-driving cars, essentially for Lyft, with an eye to be specifically focused on the needs of rideshare. And I founded this group and I've been leading it ever since. It was about 3.5 years ago. Prior to that, I was at Google for over 12 years. And there, that actually a pretty interesting story. So I came to Google to work on Google Books. I was intrigued by the ambition of Google to scan all the world's books. But Google at the time was encouraging engineers and just about anybody at the company to have side projects that we call the 20% project if they saw value. And so I got interested in a project that was a collaboration between Stanford and Google, which had been in fact spearheaded by Larry Page himself. Larry Page is a founder of Google, one of the co-founders, sorry. And the idea was to just collect imagery at street level from vehicles driving around. And his vision was, essentially to not just bring the web to people, but bring the world to people. And you wanted to collect data at street level and make that useful in some fashion. So the vision was still a bit fuzzy, but aligned with Google's overall mission. Since Google was growing very fast, there was really nobody at the company at the time, so that had actually spent any time on this project. So I took that on as my 20% project. I managed to get some interest from a handful of other contributors who helped me out. I managed to hire the first summer 7 interns to help me out. And so this first summer with 7 interns, myself, product lead, and then another handful of people, we managed to put together kind of an end-to-end demo of what something like this could look like. So we put together, we hacked the car together, with a bunch of, cameras and LIDAR and hardware in the car. We got help from the security team at Google to drive this car around to collect data. We managed to establish some very early and clunky way of getting data out of the cars through hard disk, being plugged into a kind of under somebody's desk, uploading. And then we managed to put together kind of end-to-end computer vision pipeline to make this data useful. And, at the end of this summer, a couple of weeks after that, we had enough to talk about the project. I gave a tech talk. Then we had a review with the VP of engineering at the time. They thought it was interesting, and then they gave us, the real go ahead to actually make this real and hire people. So at that time, we were able to go on and start hiring, engineers to work on this. And about a year plus later, we launched in 5 cities. Why 5? Well, we wanted to, from day one, sort of show that the project was not just a California experiment, but had an ambition to grow beyond a single city. So we decided on 5 cities spread across the US. Still very small amount of data in each city, but useful. And from there, we, want to, sort of see what happened, right? It's a brand new product space. Nobody had launched street level imagery before in the context of maps. We managed to, have record traffic and record, press interest in the product. So from then on, we knew that, well, this is going to work. This is something that people want. And so we were focused on then the scale, growing this product from an early stage experiment to something that could be scalable. And I guess my focus over the next few years was that scale, was to make this real, to make it more robust, to essentially rewrite everything about the software we had built, because everything was sort of clunky at the time. It was all about moving fast and not about having something, super reliable. And so along the way, my career grew. The team grew from, a handful of people to over 100. And we had global operations as well. And after that, I also expanded my scope to be interested, to be involved in imagery of different kinds, imagery captured from airplanes, from satellites, from users on cell phones. And essentially the mission became to make sense of all this imagery in the context of maps and to derive data for maps. So not just about presenting images to users through Street View or Google Earth, but to go from essentially raw pixels to knowledge and structured data. So today, in fact, more and more Google Maps, and I assume other companies' maps, are built automatically by data mining imagery and extracting from that the sort of street signs, information about street names, house numbers, and all the information you need to make a map. So we pioneered this along the way and expanded the scope of this to derive knowledge from other kinds of imagery at Google. So that's my story at Google in a nutshell.
And so were you collecting data via LIDAR or radar, I guess, in the early days, and you expanded to use all different sources?
Yeah, so the Street View car was primarily about imagery. But we, from the very beginning, felt that there was going to be interesting information that we couldn't easily derive from the imagery. And that was about the 3D of the environment. And the reason for that was that we wanted to be able to give you a smooth transition between panoramas. So imagine this: if your Street View images are like a bubble, right? And when you navigate from bubble to bubble, it can be very jarring if there's no transition, right? You're just like, you lose your context. And in order to give you a very smooth transition from one bubble to the next one, you need to be able to essentially take the first bubble and warp it in a way that it sort of moves to the second one. And the warping involves understanding 3D. So what you do is you project the imagery onto 3D, a coarse 3D of the environment, and then you sort of move the user smoothly to the next bubble. To do this, you need 3D. So you can, in theory, reconstruct the 3D from the raw imagery itself through stereo, but it's complicated and not always, doesn't work always great. So to help us along the way, we put LIDARs on these vehicles. We started on the very early days of the project with LIDAR that had like a single line. And then over time moved to LIDARs that were much more sophisticated and had like the puck style LIDAR that gave us more information. So yes, it was primarily imagery, but we also had LIDAR.
How do you compare the differences in the quality of data from LIDAR versus radar?
So that's, completely different. I think we can maybe talk about this, when we move into the realm of autonomous driving. LIDAR is, very rich data that, essentially it's a point cloud that gives you distance at every point in the scene, right? Typically, at least if you talk about the LiDARs that are the puck style, they are rotating lines like this. Now, radar is very different. Radar is is kind of raw data, and it's very hard to interpret. It doesn't typically give you just like distance to one object or the dominant object in the scene and velocity. Now, there are new generations of radars that are becoming commercial at the moment that are called imaging radar, and that gives you many more returns. And in fact, can give you something that looks like a coarse image of objects and distance and velocity. So it's and the two have different characteristics in terms of how they work in different weather. So when we talk about AVs, I think the beauty of having LiDAR and radar and imagery is that you can somehow always have something working well for all the weather conditions you encounter and for all the situations you need to be able to deal with. So they're complementary.
And does the Maps product that Google have give them any advantage for Waymo in AV?
So the answer is that some advantage, yes. I think there's a difference between what we might call traditional maps that as like Google Maps that are mainly for people, right? And what we call AV maps that are also called HD maps that are designed for machines, right? For robots, for AVs. So for most humans, you don't need the level of detail that you need to provide to an AV, because we also have, a lot of experience, intelligence to, take the course information and sort of map this into the world we see around us and navigate. AVs are different. AVs, um, have a lot, that they need to do in a very short amount of time. They need to understand the world around them. They need to understand what, other agents are doing, pedestrian, other cars, trucks, what have you, and then plot a safe course of action. Right? Doing all this in essentially real time is very expensive. If on top of this, you also need to understand the static environment, right? Understand, the lane configuration, the intersection, the stop signs. You need to do even more work, and you are CPU limited. So every AV company today relies heavily on what they call HD maps, essentially a pre-recording of the static environment that is preloaded in the vehicle and can be used then. And these maps are really, think of them as like 3D models, so a 3D model of the environment plus metadata that matters, like exact location of stop signs and lane boundaries and traffic lights. All these
That's all
things
proprietary to each company, that metadata?
That's a great question. So at the moment, yes. However, there are companies that are trying to build a business in providing AV maps to the industry. So I think the first one was probably a company called Hira Maps that been trying to go into this business and to provide HD maps. And there are others. There's a one that it's called Deep Map, that was founded by former Google engineers, that is catering to the AV industry by creating these maps. There is, however, no, agreed upon format. There's no agreed upon level of detail. Some companies do something, online, meaning in real time, versus in the map. People place the boundary differently. So I would say that at the moment it's still kind of the Wild West in HD mapping. And I think over time we'll probably see more sort of consolidation or standardized formats, but that hasn't happened yet. So going back to your question about Google, I think Google or Waymo uses the some of the Google Maps for the underlying sort of structure of streets, right? But they also augment this with their own mapping efforts, right, for HD.
Right. And can you lay out the AV stack then, from hardware to the behavior and perception and stuff?
Yeah. So you often think of this as like a layered sort of set of components, right? So the lowest level, you've got the vehicle that you need to interface with, and so that typically requires a deep integration, through various vehicle components. And that's so that you can control the vehicle, right? Essentially, you need to be able to tell the vehicle, to apply the brake, turn right, turn left, accelerate, put the blinker on, and all these things, right? Even control the doors, to do all this programmatically. So that's kind of the lowest level is the controls. On top of that, the controls themselves, it's a pretty complicated piece, because when you apply the brake, the vehicle will do different things depending on whether it's on a slope or if the road is slippery, or the weight of the vehicle. So there's a whole bunch of work that needs to happen to sort of understand exactly how the vehicle reacts when you apply the brakes, for example, and do smart things to give a safe and sort of comfortable experience to riders. So that's the lowest level. Now, all right. So on top of that, maybe I'm going back, or I should go the other direction. So let me actually try the other direction. The vehicle, first of all, needs to understand also where it is. And so part of the stack is that localization piece. That is done using a combination of sensors. You can't rely just on GPS. It is not, precise enough. GPS also can, be blocked by tall buildings, and so there's too many issues with it. So what you end up doing is relying on these maps that we mentioned earlier that are preloaded in the car, and you use typically the LIDAR, one of the sensors in the vehicle, to to sort of get the kind of a course map of the environment around the car, which you match to the known map, right? And you can restrict the match using, of course, your knowledge of GPS, of course localization. So you map precisely where you are, and then you don't have to do this all the time. You can do it only, once in a while, because then you can rely on other sensors like the IMU to know how much you've moved in between. So you can pretty much get from this kind of system centimeter level accuracy localization, right? To precisely where you are in the environment. So the sensing stack that you have, all the sensors, so the cameras and the LIDARs and the radars, right, are also used for what we call perception. So the vehicle, sort of knowing where it is, also needs to understand the dynamic agents, right, itself. So it knows all the static because of the map. You know where you are because you're localized, and you have the map, therefore you know the static. Now, dynamic objects need to be found, and they are typically found through a combination of LIDAR, radar, and cameras. And there's a lot of them looking all around the vehicle, right? So once you have sort of localized and sort of detected all the objects around the vehicle, you also have to predict their motion. That is the prediction piece. Oftentimes that's done at the same time as, you can imagine doing perception prediction at the same time as one block, right? So what you do with this is you sort of predict for each object, each agent, what it's gonna do over the next few seconds. The simplest way of doing this, courses, would be this ballistic rollout, right? You just take the velocity and project out. It's not very good, of course, not sufficient. Vehicles move differently depending on the street configuration. If the road curves, they will continue to curve. If there are other agents they need to avoid, they will avoid them. So the prediction can easily get pretty sophisticated, right? And once you have, again, all the agents and their predicted behavior, then you plot the right course, around these agents. That also takes you closer to your goal. So you have a goal, you have to get to some destination, you have the map, you have all these agents, you have the rules of the road, and you do what's called the planning piece, which is to get the best possible sort of path, safe path around the agents. And that's the planning piece. So that's sort of, and then you execute the plan through control. So you turn the plan into a set of actions, that the car will essentially, execute, meaning turn left, turn right, apply the brakes, etc. You do all this very often. The typical is like 10 hertz or 20 hertz is a typical, and that's why you need a lot of compute power in the vehicle. So we talked earlier also about the sensors that are in the vehicle. You also need a ton of compute because doing all this is expensive. And so what's in an R&D type environment, when you're building your stack, you would typically have very beefy computer, say a multi-core Xeon type, data center type machine. They are with also a lot of GPUs, from like 4 to 8 high-end GPUs to primarily be used by the perception, which uses most GPU power. That's what we have typically.
And so really, when we're looking at the real differentiating piece of the stack, is it that proprietary data set and really how these companies collect data and the quality of the data that's going to define who has the best solution?
Yeah. Well, data matters a lot, right? You need data for testing, right? So, and the data is also specific to what we call the ODD. So ODD stands for Operational Design Domain. It is the environment that the vehicle is currently designed to operate in. So typically, you're talking about a geofence area, potentially some specific routes. Potentially, you're talking about weather conditions that the vehicle is designed to operate in. Perhaps when you're building your stack from the ground up, you will start by doing only good weather. You will also build the stack to work during the day, where it's easier, not at night. So that's the ODD is defined, right? And so what you typically want to do is collect data from your ODD, right? And then measure your performance on this ODD as well, on this, these routes that you're designed to work. So that's why data collection matters a lot. So the more, I would say the larger your ODD, right, the more data you need, right, and the more testing you need to do, right, and that's why you see companies like Waymo, that's one of the most advanced in our field, having hundreds of vehicles and testing in many cities, because they need to be able to sort of be exposed to a large range of situations, and as a matter of fact, the more advanced your capabilities, the more you are not seeing anything interesting for miles and miles, because you're able to deal with all these typical situations very well. But in order to see what we call the long tail of situations, which are things you see very rarely, and to test the vehicle against those situations, you need to drive even more. And so that's the issue, the conundrum in this business, that you really need a ton of data to be able to to sort of bring a vehicle to market in a safe way, an AV to market. Yeah.
And it's not just the volume of miles, it's the quality of the miles driven, right, that it gets exposed to.
Exactly. So if you only drive, for example, highway miles, that's not going to help you all that much, because typically not really much happens in highway miles, most highway miles. So yes, you're right that you need to somehow be able to get exposed to new things. So, for example, in the realm of perception, there are some particular agents you don't see very often, like maybe police cars or ambulances or fire trucks. And so, in order to test and make sure your stack works well against these kind of agents, it is a good idea to perhaps go drive around police stations or hospitals or or fire stations, for example, to increase your likelihood of seeing these agents, and therefore be able to train on them and be able to improve your stack. Yes.
And so comparing the approaches that different companies in the space are taking to building out the stack, and I think starting with Tesla, as they seem to be a lot, I guess the most vocal, specifically Elon Musk, about this. How do you look at firstly, the kind of radar approach that they're taking and this whole neural network that Musk keeps discussing? How do you look at their position in building out the stack and building that database?
Well, I mean, Tesla is pretty unique, right? They have a way of getting data from the entire, fleet of vehicles, which is powerful. It's an asset. Other companies can do that as well, but I think Tesla is uniquely positioned to do this. However, they're also limited in what they collect. The vehicles have, cameras and some radar, but don't have any LIDAR, for example. So that limits, I think, what maybe the rate of progress that they can make. And I'll get back to this in a minute. In terms of compute, they have been pretty advanced in very quickly building silicon, for doing some of their I guess their inference, mostly their machine learning in the vehicle. I think they just announced recently a new generation that's going to be even more powerful. So, and this is important because when you have in order to have a commercial vehicle, right? You can't be using 5 kilowatts of power to power your AV stack. It is impossible, right? It's first of all, it would reduce the range of your EV in this case dramatically. It would bring way too much heat. It's too expensive. So you really have to move to silicon over time. So they are pretty advanced on that front. I think their challenge is that they don't have any LIDAR, and LIDAR, I think, is pretty critical to allow you to perhaps train on fewer miles, build a stack that will perform safely, even if it hasn't sort of seen the super long tail of events. So to give you an example, I think the way the stack of Tesla is built, for at least for perception, right, is based on sort of training, on large amounts of miles from camera only data, right? But when you encounter something completely new, you know what to do. And so the example that there's new example every month, but one recent one was a Tesla in autopilot mode on a highway in, I believe, Taiwan. And there is certainly in front of that vehicle, there's like an overturned truck. Well, I guess Tesla hadn't trained their stack an overturned truck, right? So I think this perception stack doesn't know what to do, hasn't seen that. So what you always have this conundrum of you think something may be off, but you don't want to always hit the brake when you think something may be off, because then comfort is compromised, as well as in fact safety. If you hit the brake unexpectedly, somebody might rear end you. So this video is on the internet. It's very interesting. You see a Tesla essentially going straight into the overturned truck. At the last second, maybe it applies the brakes. And why is it doing this? Because it relies purely on vision. Hadn't really seen this object before, right? And therefore it didn't know what to do. I think a LIDAR first approach, has a chance of getting over that hurdle, more quickly and more, more safely, I think, because you can first and foremost build a 3D model of the environment, right? That's what you do with a LIDAR. And if you see that there's something big, that is somehow in your path, then you apply the brake. So I think it allows you to probably train not on, billions of miles as Elon Musk has said, but on a much lower amount, and still be safe.
And are they collecting just images versus video, or are they using video for all those data, all those miles collected?
Honestly, I don't know. I suspect that they collect snippets of video. They can't spread too much data to upload everything. So my sense is that they have come up with like a smart way of deleting the boring miles and uploading the thing that are novel and interesting and potentially that we can train on. So I suspect that only a small fraction of the data collected by each vehicle is actually uploaded back to base to train on, right? So there's a bunch of smarts there, but it's probably video, absolutely.
But then they're going to have to have certain events that would trigger that sending over the air, right? So like, I don't know, like you said, a really hard brake or swerve.
That's right. That's exactly it. So they use other sensors. They use, events from maybe some logs from a perception, some hard brake information, some other signals. So, and that's a whole logic you have to put in place and to build.
Are they limited about what they can send over the air?
Well, I'm sure they are. So first of all, they don't do it, in real time, I assume. Again, it's all speculation. I don't know how they do it. They haven't talked about it, right? My suspicion is that when you bring a vehicle back home, right, and you charge it, that's when they maybe, start uploading interesting events. They must have a smart upload, approach, that does it, when the vehicle is idle, and of course doesn't upload everything. So they are very interesting. They're unique in the industry. There are others that have, another app, that are also collecting data from cars. That's the one that comes to mind is Mobileye. Mobileye, now owned by Intel, has built, I would say, level, sort of safety systems, level 2 type systems for vehicles for a long time. And they have also built silicon that is very efficient. And in their case, they, this system that they put in a lot of vehicles uploads as well some very, very small amount of information, some snippets that are essentially patterns in 3D that they observe, that they use in aggregate to make 3D maps and keep the map fresh. So it's a very interesting approach as well. It only works because you have so many cars with the Mobileye system.
Is there a situation in where technology and compute power can kind of bypass LIDAR and go to kind of some next level where, they have the neural network that the Tesla has can kind of bypass and create a better map with the compute? I'm just trying to think of ways that maybe you can get around LIDAR. Is that possible?
Well, I mean, I think with enough training data, you can bypass LiDAR. You can also use stereo, to get depth, right, information. So LiDAR is not 100% critical. There's probably ways around it. But LiDAR is also becoming very inexpensive and less unsightly than it used to be. It's no longer that you have to have this giant thing rotating around top of your car. Now there are many companies making sort of a very small and high performance solid state LiDARs that you can probably embed around your vehicle. So I, if I were Elon Musk, I would look at these, very, very closely and eventually put them in cars. It's certainly, LiDAR may not be 100% critical, but it does make the problem a lot simpler, right? And so therefore, it's a pretty good idea to use it. And I think probably 99% of companies use it. Only Tesla doesn't use LiDAR at the moment, as far as I know.
And so Waymo, for example, they have hundreds of vehicles in certain areas, like Phoenix, I think was one where they have LiDAR on the top, which is collecting data specifically in that area.
So again, LiDAR is not just to collect data; it's to collect data as well as to, be a critical sensor for the perception. So it's used both sort of in real time and offline for the map. By the way, I believe they have more than one. They have now five LiDARs. They have like long range ones and short range ones. I believe they have some behind the mirrors and one in the front, one in the back. They may even have 6. I forgot. So it's a large number of them.
And so back to where the value is in the stack then. So like you said, it's really at the perception layer at the top, really almost emulating the behavior of a human to really drive the vehicle in a certain way. And therefore, as much quality data and perception is required in the vehicle.
So, I mean, perception is one piece, right? Perception, I would say, when you look back, say 5-10 years ago, when the field of autonomous driving was sort of, ramping up quickly, I would say at the time, the, AV stack was often associated with perception, right? You often saw these images, with 3D bounding boxes around objects, and that's what most people thought. I guess the complication is perception, but turned out that perception has made tremendous progress over the past 5 to 10 years, thanks to deep learning and thanks to these new advanced sensors. And so, I think my view is that perception is no longer the thing to solve, right? There is a path to having something that's good enough and safe enough, right? The biggest challenge is really the planning. How do you plan around, the environment, where it's always safe and provably safe, right? That's where I think the biggest challenge is. Most teams that started in this field were roboticists and apply sort of robotic type approaches to the problem. So essentially trying to come up with rules and tweaking the rules based on a large number of parameters. And that approach, I think, is maybe at the moment showing its limits because there's so many different type of scenarios you need to be able to deal with, right? And also each scenario, in order to be really good at it, needs to have tens, maybe even hundreds of different parameters it sort of weighs in, right? For example, even just going around a bicyclist, right? That's on the bike lane on the right. You have to take into account maybe their speed, the lanes around you, the other vehicles that may be coming. Is there also a traffic light that's coming up? Is there? So you can easily sort of start adding dozens and dozens of different parameters that you have to tweak, and that makes the problem very, very challenging to solve. You need probably lots of engineers for each maneuver, and so one thing that I personally believe, and an approach that we've focused on at Lyft Level 5, is to build more of a machine learned approach to this. And based on data, build a system that will sort of learn from more data, and the data in our case, Tesla will collect that data from their vehicles. We will collect the data from sort of the Lyft fleet by adding some sensors on some of the cars at large scale. So that is the approach. So again, going back to your question, the perception I think is sort of primarily I think on the way to being solved. The current crux of the challenge is in planning.
What is the real challenge in planning for companies like Tesla or Lyft or Waymo?
Well, I think the challenge is first off to be able to handle the long tail of situation you encounter. Right, it's easy to what most cars do. If you look at the time on the road, and what they do is lane follow. So they are just on a lane and typically following the car in front. That's the most. So that's the first thing you work on, and you solve that pretty quickly. But then then the next thing they do maybe is turn right at the intersection. Then you keep going down the list of things that you need to be able to do, and you end up maybe at the end of the spectrum you have to deal with some deer that's like jumping from the bushes and in front of your car.
Right?
Okay, so it's unlimited, right?
Yeah.
And so that's the thing. That's the challenge. And how do you somehow deal with all these situations and be able to prove that you're safe enough, right? And what's the bar? Is the bar to be as safe as a human, right? Probably not. I think you probably want to be even safer, right? So how is safe? How do you prove it? Then there's a challenge also of demonstrating that you're safe in the presence of some hardware failure. Right? It is very possible that you might have a camera suddenly is obstructed by say bird poop, or that you lose a piece of your computer due to overheating, or any number of things could happen, right? Or you have a flat tire. What do you do then? Are you able to do a safe maneuver? Can you prove that? And that's often again done through sort of safety decomposition of the whole problem, and understanding the path, and that can be sort of essentially provably done, but it's hard. It requires a lot of work. So you've got that approach, proving that things, the right things happen in the presence of the hardware failure, and then also proving statistically that you're safe, as safe as a human, or X times safer than a human in the ODD you're operating, right? And that requires a lot of mind. So that's the biggest challenge, right? And then you have to be able to communicate this and to regulators, to the public, and that's probably the challenge of the day with AVs.
And can we move on to look at the different business models potentially in AV? And so I think we saw one where where you have the likes of Waymo, which is partnering with Magna and partnering with the tier ones to kind of build the fleet. I think they're building Jaguars or Fiats with LIDAR on. How do you look at the different, obviously the ride hailers like Lyft and Tesla? How do you look at different business models potentially?
Yeah. So great question. So I think there's probably, broadly speaking, 2 or 3, right? Some companies are building what I would call the SDS, a self-driving system. And their model is to be able to sell this to OEMs, right? Largest number of OEMs to integrate. That would be a company like Aurora, for example, a startup in Palo Alto, California, that's doing this. So it's pretty simple. They become a tier 1, right? Tier 1 providers to OEMs. There are companies like, let's say, Zoox, which has now been acquired by Amazon, but let's say Zoox, that are clearly in the robotaxi business, right? And so what they want to do, and Cruise as well, is build a service, right? So they don't need to integrate with too many vehicles. That is, you have maybe one vehicle at least that work to launch a service, and then their business model is to simply provide just like Lyft or Uber, a service, but a service powered by self-driven vehicles, right? And then you have some that are more hybrid. I think Waymo is maybe this more hybrid approach, right? It's both partnering with companies like I think JLR and others, and might want to license the Waymo driver to some of these companies. I don't know the specifics, but they're also interested in building the service, right? The Waymo One service, which is a robotaxi service. Now, in the midst of all this, you've got companies like Lyft and Uber, and sort of ride-hailing companies of today that are building this, for themselves. And so the plan here, the business model is to add AVs to complement your drivers with AVs, right? In the case of Lyft, these AVs will be either our own AVs built by the level 5 team, or they will be third party that we sort of onboard on Lyft. And there are already some pilots on this. There's one with Waymo and one with Aptiv currently. So that's roughly the business model.
And then Tesla, I suppose, is somewhat similar to the ride hailers.
Well, I think that's very interesting. So Tesla, first off, they want to sell you, full AVs, right? In fact, they're already selling you, I would say I've read that 2/3 of people buy their Tesla with like a full self-driving package, even if it doesn't really exist yet, right? But, eventually it will. One would hope. And then I think, Elon's vision is that you can monetize your Tesla when when you're using it by putting it on some sort of network where it essentially operates as a robotaxi. So I think Tesla's model is unique. My personal opinion again here is that most AVs will probably be operated as part of fleets, and at least initially. And the reason for that is that they'll be pretty expensive still. The all the equipment, the collection of sensors you need, the redundancy needed, the compute, all this is pretty expensive, easily tens of thousands of dollars, probably more initially, right? And so that's not something that, as a consumer, you would feel like spending just to get your car to drive you autonomously, on occasions, right? It seems overly, a too small a market, right? Of course, if you can make that super cheap, as Elon Musk is hoping to, then it becomes maybe more attractive. But until that happens, I think only robotaxi providers and rideshare will be sort of using AVs and getting value from them, because they can really keep them on the road a large fraction of the time. So they can amortize the price over many, many miles very quickly.
And then do you think that those businesses that have a relationship already with customers, the end users directly, have an advantage?
You mean Tesla or?
Like Tesla or Lyft and Uber have a relationship with customers as well?
Yeah, I think so. Lyft and Uber obviously have an advantage because the service exists, right? So there's millions of users using these services, every day. And so you can, deploy AVs as part of the service very naturally. The go-to-market sort of, approach is very, very obvious, right? As an advantage. I think, others, again, like Cruise and Waymo, to name, probably the most prominent ones, will have to build up their own service, right? And I think also the service will likely be, limited at first, operate only in some cities, and maybe not operating all the time, or maybe not every single, desirable pickup and drop-off location will be supported. So it's going to be a challenge to build a really great product, from day one, with only self-driving cars, not just in terms of like, technical challenges, but also in terms of like building the brand and the service and the customer base, right? We believe that, people want to have like 5 different, apps that they use for ride hailing, right? When they want to go from A to B, they'll probably end up, with 1 or 2, or maybe even 1, right? And so the question is, can these robotaxi providers eventually be able to operate everywhere so that you only use them? It will take a while.
Well, and that's the advantage though. If I've got Uber or Lyft downloaded on my phone, I'm not going to really want to download a Waymo app to hail an AV once every month when I do a specific journey. Or it's very hard for them to get to scale to put that actually into the service.
Well, I mean, we should not underestimate them, right? They will find ways to give you coupons, to the beginning to make it cheaper, right? So they will find a way to attract you. They will, find ways to get distribution from like Google Maps or other places where they can get discovered. So there will be ways for them to build the brand. But yes, otherwise, I think over time they will require them to to be in many cities. Another way they can be discovered is by say if you're um, using Google Maps, right, for example, and Google knows your route. You're trying to go from where you are to some destination. They can see if that route is supported by the AVs, right, by Waymo AV, for example, and if there's one nearby, and then propose it to you at that time. So there's like ways that they can build their brand over
ways.
time.
Yeah, I mean, everyone uses their products, right? I guess
Yeah.
the question
Yeah.
is like, at what scale do they need to get to make it, I guess, make a dent in what they're doing, but also just around, the cost of those rides in the early days.
Yeah,
Which
exactly. I think early days are going to be super expensive, right? And so that's why, we believe that the right model is to have, at least in the early days, a combination of driver and self-driving cars. Maybe your AVs are, first of all, the AVs are very expensive, right? And the demand in this business is very, very spiky. You will find that there's a peak of demand in the morning commute. There's a peak of demand, in the evening commute, and a peak of demand in the evening when people go out. That's sort of every day is about like that. And so between the peak demand and the middle of the day, which is like lowest demand, there could be 5x, 10x difference, right? So if you are building a service that you want to be available all the time when people need it, you need to be provisioned for peak demand, which means that your cars, most of the time, will be idle doing nothing. So what do you do with them? Well, maybe they can deliver packages or do something else. It's possible, but mostly they do nothing. And so if your cars are very expensive, then your business model doesn't really work, right? And so we believe that the early days when your cars are expensive, you use them for you have a few of them or maybe a small number of them, right, that are doing your base demand all day long, right? But then they are complemented by drivers for either the peak demand times or for rides that these vehicles are not able to do yet, right? So the combination is very synergetic. And since by the way, since the business is growing and the market, despite recent hiccups and headwinds with COVID, we believe that there's a secular trend of people moving to rideshare or to not owning a car, essentially moving to using a car as a service. Uh, as this market keeps growing, you will, even though you deploy AVs on your service, you are still going to need more drivers because the demand still grows. So we will see this, I would say, play out over the next 10, 20 years.
And how do you look at the role of the OEM in let's say, I think Waymo, like you said, Waymo partnered with Magna, the tier one, which then partnered or to manufacture cars for, I think, like you said, JLR and I think Chrysler. Well, how do you look at the role of the OEM?
It's certainly evolving. I would say, first of all, I think if you look at the past few years, car sales have not been, doing great worldwide, with the exception of, again, Tesla and a few others. And the reason for this is that, again, there's been, move to rideshare and fewer people owning cars, and that trend will probably accelerate. So the OEMs are under pressure, I think, and need to sort of reinvent themselves. They also don't have, I think, the DNA and the people they need to build, the really deep, machine learning and self-driving engine that they need. And so that's why you've seen lots and lots of partnerships, between sort of tech companies focused on AV and OEMs. And as a matter of fact, these tech companies as well, typically have like a software DNA, but they don't know how to build cars. So there's clearly a need to partner, and that's why we've seen lots and lots of partnership in this space. You've named a few, there's probably many more that we can name if we do a web search. I still think that over time, if you believe, if you agree with the thesis that people will over time not own a car, but rely more and more on kind of transportation as a service provider like Lyft or Uber or others, right? Then I believe, again, this is my opinion, that the brand power will probably migrate to these networks, right? Which would probably mean that the OEMs, their role will become more as like maybe tier ones to these sort of services that rely on them, on their vehicles. But still, again, building cars is very hard. It's regulated. It requires decades of experience, and so the OEMs are not going away. They are pretty critical to this whole ecosystem.
But they're being pressured to become almost like a pure assembler, even though they're an assembler now, but just without the brand potentially, because the brand will shift to those who have the relationship with the customer, which will likely be Uber,
It's
Lyft.
possible. Yeah, it's a scenario that certainly is logical, but I think it's going to play out over a very long time. Yes.
And the tier ones as well, right? Because again, they're in a tricky position. If I guess everyone will get squeezed in that the values actually shift into that, like you said, planning and perception layer, which is actually software or technology, which is owned by not the tier ones and the.
Well, I mean, some tier ones are also trying to build self-driving systems, right? For example, again, Magna was one. They may have scaled back their efforts recently. Another one is again Aptiv. They are a tier one, and they are building a full sort of SDS, and in fact they are sort of testing it on Lyft.
What's your opinion on Aptiv? I mean, because they've got level 2, level 3 systems, right? Is that difficult? Is that a whole different ball game getting from level 2 and 3 to 5?
Yeah. Well, so I don't know about Aptiv specifically. I can't really comment on them, but I think yes, you're right that some players, typically the players that are coming from the auto industry, whether they are OEMs or tier ones, typically will start their journey in autonomous by doing level 1 and level 2 and level 3, and then eventually hope to go the biggest hurdle is going from level 3 to level 4, and they are they have to somehow fund their way to level 4 through products that are that they can sell now, right? But the jump between level 3 and level 4 is very substantial, and you'll find that many pure AV players coming from a tech DNA or Silicon Valley and other places, right, go straight to level 4 and say like the rest is a distraction. The crux of the problem is to build this level 4 capabilities, and they go straight to that. And that's will eventually one day we'll know who's right. Also, I would say the tech company, the AV companies are usually focused on the raw autonomy capabilities, right? So they're trying to demonstrate some level of performance, of the autonomy system, without worrying too much about the underlying hardware stack and vehicle, right? They take the opinion that there is something you can solve later. I would say typically traditional automakers, OEMs, and tier ones will put a lot more focus early on the underlying foundation and get that right. So get the right hardware stack and sort of real-time OS, and sort of the middleware layer that's auto grade that they can build on, right? So it's a different approach. I think we need both, and over time, I think we'll probably see probably partnerships that build on the strengths of each, and that's probably already what we've seen on these partnerships between sort of OEMs and tech companies.
What's your view more broadly on putting these questions together and how the automotive value change will evolve?
Well, I think we've already sort of touched on this. I think we'll probably see, again, if you agree with the thesis that over time more and more customers sort of or users ditch their cars and use instead a service for most of what their needs, then you will probably see vehicles being designed for these services, right? And that means that they will be more autonomous, but they will also, last a lot longer. They will be designed for very high duty cycle, and sort of therefore they need to be more robust. So we'll likely see, in my guess again here is more sort of fewer sales of vehicles. We don't need as many, right? Because they are more shared in these networks, right? But they will be much more robust and able to maybe go 500,000 miles or more. And of course, it'll be autonomous. The other trend that's also pretty obvious is that they'll be electric. I think it's something that is happening now. So fast forward to maybe let's say pick a number 10 years from today, you'll see fewer cars worldwide. I'm sure of this, right? They'll be electric, they'll last a lot longer, and they'll be autonomous. That's kind of the trend, in my view.
And I mean, what is the time frame that you're really realistically looking at for AVs?
That's a great question, and I think probably all of us in the industry have, I would say, lost some credibility, here, because some extremely ambitious and optimistic predictions that were made some time ago about the deployment timelines. So we could say it's going to be less than 50 years. That's for sure. I'm pretty sure of that, but much less probably. But I think we're not there yet, right? The fact that my view is that the big players, again, Cruise, Waymo, have all announced deployments for autonomous services, and then sort of push them out and push them out again, and are not yet deployed really in any meaningful way, right? And in fact, you see some of them also getting into non moving people, right? For example, Waymo is now going to trucking, for example. And I wonder why. One can speculate that this is because they are still not ready to deploy sort of commercial AV service, passenger service. I mean, and therefore they are trying to get value in an environment that's where the tech is a bit less complex. So with all this said, so going back to your question, timelines, my expectation is that in the next, let's say, couple of years, right, we'll see really some very small scale deployment, and again, it's going to be in what I called earlier OGDs that are pretty simple. We'll probably see the Cruise and Waymos of the world scale back their ambition and maybe try to deploy somewhere small, right? At the same time, there's other players that started small and might want to expand. So for example, there's players like Voyage, a California startup that's been focused on the retirement communities and maybe gated communities, environment where are more controlled, where the speed limit is 20 miles an hour, and so it's a small market, but you can use that as a beachhead, as like a way to sort of build your service and and grow from there. So I think we'll see in the next couple of years some success at small scale from both ends of this market, right? From the smaller players focused on very specific ODDs, and from the bigger ones being more focused. And then we'll go from there. I think it's still going to take a while. And there are some, in fact, in the industry that speculate that we need maybe even a breakthrough in AI in order to really be able to deploy AVs at scale, right? And it's true that our system right now are built to imitate the human. They cannot extrapolate a new situation thrown at them. They can't extrapolate. You can only deal with what you have seen before and been trained on, right? A human is able to extrapolate. Is able to, a new situation is presented, they can somehow do something safe.
Right? So you need that jump then in machine learning.
That jump exactly hasn't happened yet, and there are many AI luminaries that are working on this right now. The extrapolation piece, but we may need this in order to really have safe AVs, at scale.
Isn't Google in the best place to make this jump, given their ML and AI?
They certainly are. I mean, they are certainly uniquely positioned. But who knows? I'm not there anymore, so I can't speak for what they are doing. Certainly, one big factor in all this, which we haven't talked about, is that building an AV takes a lot of money, right? It's an AV stack. Why? In part because you need a lot of people, of expensive engineers. That's number one. Number two is regardless on how much you rely on simulations, right? You still need cars on the road to test. Therefore, and the more advanced you are, the more cars you need. So say tens to hundreds, and that's expensive to operate. You need safety drivers. So that's expensive. And then last but not necessarily least, you collect a lot of data that you use for machine learning, and therefore your cloud costs, are significant and only grow because you have more and more data, and you typically train more and more models over time. So add it all up, it's an expensive proposition, that's why I think Waymo as well. But some players have unlimited money. Apple is working on this too. They're not making much noise, but they definitely are investing. Google, and then the biggest players have raised billions and are able to sort of invest, in this for the long run.
Do we need something like 5G as well? Because these cars, I guess, are just moving data centers effectively, right? So do you need a different infrastructure as well?
Well, that is a great question. I think, first of all, you should not, in my view at least, build a vehicle, an AV, assuming that you'll be 5G connected the whole time, because that may not happen, and that'd be unsafe. So you have to, sort of assume the vehicle can operate on its own in the environment without connectivity. Now, with this said, yes, these vehicles collect a ton of data, and that data, some of it at least, maybe not all of it, but some of it will need to go back to base to be analyzed, to help, train and refine the training, to help keep the map up to date. So even if you don't, and by the way, an AV typically collects, multiple terabytes of data per day, right? Maybe say 10 to, as a minimum. So to upload all this, every day, maybe you don't want 5G, but maybe you just, even with 5G, can't deal with it, and go back to base to some sort of AV hub, right? And there get that data sort of uploaded over wire or even Wi-Fi. But yes, data management becomes a big piece. 5G could help, absolutely. I don't think it's critical. This is my view.
And so when we look at, Tesla's plans and potential, full self-driving in the next couple of years, it's pretty unlikely we're going to see mass Teslas around that are driving everyone autonomously, right?
I don't think so. My best guess is that we won't see autonomous Teslas for many years. But again, Elon is, he's succeeded against all odds, and he's built an amazing company. I own a Tesla. It's a great car. So I would not rule him out for sure.
Do you drive it on autopilot and autonomous?
No, we bought it 5 years ago before that was available.
Right.
Or just before. So maybe I should upgrade at some point.
Right. Luc, this has been great. Thanks for your time.
Okay. Thank you very much, William.